Hi there, this is Jacob Nash, and I'm going to be going over sampling distributions and proportions. And this is based off of Virtual SC's 5.01 assignment. So the first thing that we need to know is that we need to know that there's some things that are a sample. So I'm just saying I used to use this website, like the last time I used it was like 3 years ago, but I'm using it again. Uh, a little bit different. So sorry if things go wrong because I used this in like 2010 to 2020 and then I haven't used it since. But anyways, it is a good tool, Wixie. But anyway, so we have sample and or population. I almost said proportion, sorry. So sample is just if it's a part of the population. What is a population? A population is every single member of a group, basically. So if we're saying all what the population of males, every single male in the world. So it's sometimes a little bit easy to mix up because like sometimes they'll have questions where it's like three numbers and they're like, which one's the population? Population is going to be the biggest one. Biggest one. It's always like that. And then sample is just a part of it, whatever you happen to be studying. And there's three things that, at least in this part of the unit, we're going to be looking at. That there are different symbols depending on if it's sample or population. So these two things, the X with a line over it and that thing that looks like a letter U kind of, hopefully these symbols, we know what they mean. And what they mean is the mean. They mean the mean. And remember, the mean is just the average. So if it's for the sample, then it looks like an X with a line over it. And if it's for the population, then it's the Greek letter mu. So we got to use the right one, especially if we're doing an FRQ, because they'll be like, trash can if you use the wrong one. All right, the second thing is the standard deviation. That is basically telling us how far we are from the mean. And if it's the sample one, we use the letter S. And if it's the population one, we use a letter sigma that just looks like a cannon, kind of. And then there's the last thing that I don't think we've talked about yet, but it's proportion. And that's what we're going to be looking at in this video. And P has the sample one has a hat over it, that triangle sort of thing, and it doesn't if it's the population one. So let's look at some questions here. So even if you're doing this assignment on Virtual SC, which you might not be unless you live in that state, which by the way, I don't like that website, but I'm just basing it off of that for now. It might not be the exact same questions because they have like a regurgitated database of like 20 questions, so you might not even have these, but still should help. What happens when the sample size of an online poll is increased? Well, there will always be ones like this, the ones that just don't have numbers. Sometimes they're easy, sometimes not, but this one is easy. So variability, what is that? Variability is kind of the difference. It's just saying that there's a difference. So what happens when the sample size increases? So as the sample size increases, what should happen to the variability? It should decrease. And hopefully this is easy to understand, but if you have, let's say that we're trying to figure out how many people wear glasses. I don't know. That's the first thing I could think of. Let's say that we just grab two people and two different samples that both have two people. Well, one of them might have zero people with glasses. One of them might have both people with glasses. That's a whole lot of variability between those two samples. But as we increase the sample sizes, let's say we change it from two people to 500 in both samples, then there should be less difference between the samples. And then 1,000, a million, on and on, it should be a lot more similar between the samples. So hopefully that makes sense. Okay, a researcher who is studying social media Habits chooses 900. Okay, I guess can't draw on top of the image. Users at random at the beginning of 2016. Of these users, 82% said that they sent at least 3 snaps a day. So 82% said that. So I can tell this website doesn't seem very as good as it used to be, because I think you used to be able to draw an image. However, Snap mode executives say that only 63% users actually did. Which statement is true? So remember, it's saying, so our sample number, so how many people are in the sample, we say that by the letter N. And that is 900. And we have 2% here. One of them is saying that of the 900, 82% did. So that correlates with this. But the 63%, that doesn't have to do with the sample. That has to do with the actual population. So this question is just seeing if you know, and I know it already says the right answer, but we have two different things. We have a statistic, and we have a parameter. A statistic, luckily, what letter they start with tells you what it is. Statistic goes with a sample. A parameter is for a population. So if you see something in a magazine that's like statistics show, well, it's not for the whole population. They weren't able to survey every person, or else it would say parameters show. Statistics is just from population. So that's why the 82% is a statistic, because that only is from the 900. 63% is what it actually is for the whole population. So it's a parameter. So that one's pretty easy. All right, the Tampa Times polled 1457. Oh, I wasn't on draw. People. So it's always good to just go ahead and write what it is. So that's our N. To determine whether they put a shirt on before their pants. Of the respondents, 48% said that they put on their pants first. So our P is going to be 48%. But that proportion, remember, that's for sample. And that is for the sample. That's why I put a hat on it. But it says actually only 32% do. So that one just doesn't have a hat on it because that's the population. Now it's saying, what are the mean and standard deviations of the sampling distributions? Well, these are two formulas that we'll have to use. The mean is just always what the actual P is. And then the standard deviation is a little bit more complicated. And sorry, I should have had a hat there. It's the square root of P times 1 minus P divided by N. And 1 minus P, sometimes you might see that as Q. That means the same thing. It's just P, if you're going back to our probability unit, P is yes, N is no. I mean, not N. P is yes, Q is no, or 1 minus P is the same thing as Q. So those are what formulas we have to use. Well, luckily this one, to just find the mean, we just have to do this. Oh, 32%, but let's just make that a decimal. So that would be our mean for the sampling distribution. And when it says that, that means that we're going to be doing this, like I said, for the P hat. Now we got to find the standard deviation. Let's pull out this thing. We got to take the square root of P, which is just 0.32. What happened? Okay. Times 1 minus P divided by N, which was 1457. And that is 0.122 pretty much. 0.01 is now what said? Yeah. And there we go. That's how we know that D is the answer. That one was actually pretty easy too. The next ones are a little bit more complicated, but it's still not very hard. Let's see. 81% of the world's population can roll their tongue. Okay, so that's a population thing, so we're not going to put a hat on that, and we're just going to say this. Well, let's just go ahead and make it a decimal. We might as well. What's the probability that of a random sample of 2,000 people, 1,600 of them can roll their tongue? So now things get a little bit strange here. So it's saying it's asking for a probability this time. And something that we need to know is that we have to do when we're trying to find a probability, we can take an easy way out. An easy way out is assuming that it's a normal distribution. Do you remember what that means? If it's a normal distribution, then that means that the mean will be 0 and the standard deviation will be 1. Don't even have to calculate it. We just already know that. Remember, because it's like a bell-shaped curve, and the middle is always at 0, which is the mean, and then the standard deviation is 1 away. So, but how do we know if this is a normal distribution? We have to do something, which is called, there's two things. First, 10% rule. So we have, for the 10% rule, we would have to say the sample number, so n times 10, so I can really just say 10n, must be less than the actual population. So 10 times 2,000, that is 20,000. Is that less than the full population of the world? I would hope so. So at least we passed the 10% rule, but there's still something else that we have to do. N times P is greater than or equal to 10, and then N times 1 minus P. So N times P, basically, yeah, okay, so I'm just going to write it down. You need to figure out that these things are true, but for the video's sake, I'm just going to say they are. If you typed in those things, it is true. And so that tells us that we can assume that this is a normal distribution, so we already know that. But what we're going to have to do is remember normal CDF. We can do that into the calculator. And this time, though, we're going to do something different than maybe what we did like in a previous unit. We have to type in 4 things separated by commas. Sometimes you'll just get a list of them if you have a more modern calculator. You can just type them in like that. But sometimes it will just be like this and you have to type them in with commas. So we'll have to say the lower thing. And I know I'm being vague, but lower, upper, mean, that's terrible, mu, and then standard deviation. So, but remember, anytime we use normal CDF, things like that, always has to be a z-score. So it's saying more than them. So we're looking for more than 1,600 out of 2,000. Since this is a proportion, we're going to have to know that if we have to do this. Our x for the z-score is not going to be 1,600. It's going to be 1,600 divided by 2,000, which is 0.8. But we have to find the z-score of this, right? So the z-score of this, we're going to have to type in 0.8 minus 0 over 1, which, if we know, that is still 0.8. Okay, sorry, I just realized I messed up something here. Okay, so forget about that. So don't forget about that. We do need to find the z-score still, and it is true that x is. Let me just change color. It is true that x is 0.8. That is true. Okay. But we will use this stuff when we type it into here, but we can't do that for the z-score. Instead, we have to do the things like we just did over here, where we have to use those formulas. So the mean is just going to be the same thing as what the probability is, which is 0.81. And then, because we're doing the z-score is for the proportion thing or a probability. So that's something, it's not necessarily interchangeable, but when we're looking at the proportions, we're more thinking of the probabilities and percentages. So, and then I'm not going to do the whole formula again. Well, actually I will, because I don't know. That's the only way I can figure out what the number is. So, let's just do this, okay? Get my square root on here. I don't know if you see the time. I have an appointment at 2, so I have to hurry up this video, right? So we got, we're trying to do P. So P is 0.81. And then 1 minus P. Divided by the whole population thing. With, or the N. So 2,000. And that would be 0.008. Don't know why my voice just cracked. Oh, wait, did it round to 0.9? Okay, fine. Right, there's 2 zeros, isn't there? Yeah. Okay, now we can do the z-score. All right, I know this kind of takes a long time. That's just because I'm explaining it. That's just because I'm explaining it. So x we minus, so to find a z-score, remember, is x minus mean divided by standard deviation. And the z-score is negative 1.14. I'm just going to have to finish the work on a different thing, okay? So we just figured out that the z-score is negative 1.14. Now, remember, what are we trying to do in the first place? We're trying to find the probability. Like I said, whenever you're trying to find the probability, basically to sum it up in 3 steps, you got to first do the, I'll just put a question mark. First, you have to figure out, remember what we did. We did the 10% rule and the other thing where n times p must be greater than or equal to 10, n times 1 minus p must be greater than or equal to 10. If we figure out those things, then we're good. Then we have to find the mean and standard deviation that are not for the normal distribution, because remember, we already would know those are 0 and 1. We have to find them for the proportion. Remember the p with the hat. Then once we do that, we can find the z-score. And remember, the x is going to be a proportion. It's not going to be the actual sample number. So that's why we did 1,600 over 2,000. So basically, oh my gosh, why does it keep going off the pen? All right, so we figure out if we can do it. Then we figure out those 2 things. And then we figure out z-score. And then we do the normal CDF thing, okay? So remember, we do second vars to get to that in the calculator. I'll show you in a minute. And the 4 things that we need to do, and you always have to show your work when we're doing FRQ especially. Lower, upper, mean, standard deviation. So let's do that, okay? Second vars, normal CDF, lower. Hey, what do we do for that? That's the z-score. That's why we're finding it. And why is this the lower and not the upper? Because it said probability that more than. So we know that this is the lower or the minimum thing. And then maximum, technically that would be infinity. That's what you would write on your work. So on our work, we would just pretend I wrote normal CDF there. We would write this if we're doing our work, showing our work. We would write infinity because that really is the, and I already We know those are going to be those things because that's why we did the 10% rule, to figure out if that's what we could do. Don't type in these two things, 0.81, 0.009, right here for the normal CDF. Why is it called normal CDF? Because it's for the normal distribution. So whenever you do normal CDF, the only thing that you can do is 0 and 1 for those last two things. So, but we have to type in 91 or 99, because we can't do infinity in the calculator. But when you're showing your work, got to do infinity. Type that in. 0.87, was that a choice? Yes, it was, and that's the answer. So that one was a little bit harder, right? But it was only took that long because I was explaining it. So you got to take that into account. Now this one's the easier one, luckily. It's what we already have done. Polling organization took a random sample of 3,000 middle school students to determine how many have a dog. Suppose, okay, so let's go ahead and say that our N is 3,000. It's always good to do these things, no matter what math class you're in. Suppose that 57% have a dog. So let's see, is it saying of the population or actually? Okay, all middle school students. So see, even I sometimes have to think about it. So we're not putting a hat on that because it's saying of all, not just of the sample. Total population is 8 million. So the total population is 8 million. So we don't really have a variable to use for that. But it's saying, is a 10% condition met? What does that mean? Remember, that means 10 times n must be, let's just call this, I don't know, I'll just say j, because we don't really use a variable for that. So j equals 10 million. So the 10 times n must be, oh, wrong thing. And it's not undoing. Just the perfect time for a technology fail. Okay, it must be less than j to make the 10% condition. So 10 times 3,000, is that less than 8 million? It is. So 10% condition is met. Bam, that's it. Thank you for watching.